Welcome to Akhand Vidyashram, the first institute of impeccable wisdom, the walking, talking encyclopedia. Leukocytes, the science of white blood cells. My mission, the impeccable wisdom, knowing which everything is fully known. My greatest discovery, Divyank, the divine design of nature, with which the perfect objects are designed and created. Divyank is the reward of 60 years of integrated education. Impeccable wisdom is enlightening, and integrated knowledge is empowering. This is the whole foundation with which I have found my vision as I am talking about the impeccable wisdom as on date. Now we have come to the question of blood. First, let's try understand the different kinds of bloods we have. Then, how do we proceed and understand them very well? Primarily, there are three types of blood cells: leukocyte, the white blood cell; platelet cell, the coagulation cell; erythrocyte, the red blood cells. Now, how to remember leukocytes very well is something which I would like to start with. Never let monkeys eat bananas. That may never be neutrophil 60%, lymphocytes let 30%, monocytes 6%, eosinophil 3%, and basophil 1%. I would go by this particular picture, which more or less centers around Divyank ratio only. Next, platelet counts, which are responsible for coagulation or stop the bleeding, and that will be 2.4 millions per cubic millimeter of undiluted blood, whereas lymphocytes, I would put it around 6,000 to be perfect value. Third type of cells are red blood cells. I would put 5.2 millions as a per cubic millimeter of undiluted blood. If you can maintain these relations for the rest of your life, I can assure you, you will have no problem with respect to blood. As far as cells are concerned, these are the cells, and they would form, as I told you in the very beginning, more or less 45% of the blood volume. Composition of blood, as I've told you in the beginning, I'm trying to bring it again. An anticoagulated blood, when settles down in an empty vessel, will settle down as concentrated solids, which means cells 45%, concentrated fluid, which is 55%, and living example would be, as you can see right onto, you can see at the bottom, withdraw 5 ml of blood from by pressing this, and then put into vessel, and then take it to centrifuge, which runs at 3000 square revolutions per minute for 30 minutes. After it settles down, you'll have the ratio which you can see on the right side. This is something which I have already explained. I'm showing this again to confirm that this is how the blood looks like. Having understood that, now let's talk of the leukocyte formation, or the formation of white blood cells. As I told you in the beginning, an erythrocyte, which I started with, pluripotent cell, totipotent cell, from which all the cells have originated from. They come at the right at top, and there could be 21 micron size. From there, you get chromatid progenitor cells, which are the next in line. Then you have myeloblast cells. Having understood that, then you go to the stage in myeloid about development in myeloid stages, which go through three different forms: early, intermediate, and late, to form different cells. In RBCs, you can find how nucleus is completely removed and is replaced by hemoglobin. Since nucleus or the solid matter cannot be more than 38.2%, and hemoglobin is 35%, as a result, nucleus had to be withdrawn, mitochondria had to be withdrawn, and similarly, most of other essential parts of the cytoplasm were removed. As a result, RBCs cannot stand more than 120 days, and whole thing is formed in 21 days. But here you can see stages. Then you come to the monocyte stage, and you have basophil stage, eosinophil stage, and this. So now you can say there are two types. Cellular part with the granulites, which are basophil means blue, eosinophil is pink, and neutral is free. Then you have two without granulites, monocytes and lymphocytes. Monocytes are the one, lymphocytes are two types, B lymphocytes and T lymphocytes. At the same time, I have also shown natural killer cells which make sure that problems which can lead to cancer and other cells is well taken care by these cells. Having this particular picture is very clear. Okay, this is how WBCs are formed in myeloid. To make things even more clear, I have put this particular picture. You can see the hematocyte, pluripotent cells. Then you have myeloid blast, which lead to progenitors. Then you have basophil, eosinophil, and neutrophil cells, which three are granulocytes. They are the three grains: blue, pink, and neutral. Neutral are also called polymorphs. Then agranulocytes, which do not have granulocytes, you have lymphocytes, which are smaller in size, and you have monocytes, which are larger in size. So 2 into 3 is what we call Divyank ratio. Is also something which is very interesting to see. And I told you that around 6,000 per cubic millimeter of undiluted blood should be the leukocyte count or white blood cell count. Now let's move on to the next stage. Neutrophil cells are the first one which I have put right on top, and I would definitely say nucleus is present, number is 60%, also called polymorphs, diameter is 12 micron size, young heart-shaped nucleus, 5 lobes fitted with thin chromatin. You can see the lobes which have chromatin as a network connecting all the 5. It could be 3, 4, 5 at the same time. But I think 5 is more common from my experience. I would put it that way. Cytoplasm neutral with fine granules. Granules contain glycosides, sulfates, phosphates, nuclease, and peroxidase. And the prime function of neutrophil is phagocytosis, the first line of defense. It also centers around marginalization, how they get margined, how diastasis takes place, how chemostasis takes place, how opsonization takes place, how engulfment takes place, and how degradation takes place. These 6 to 7 stages of defense, they center around phagocytosis, is something which neutrophil is a very good example. Now let's see that particular picture clearly. In this picture you can see microbes in extracellular fluid are entering into neutrophils, are all these 3 cells. And this process is called endocytosis, means their entry into the cell. Then phagosomes formation is there. Then lysosome comes to play a role on the phagosomes, and you have two things coming together as phagolysosome. They are 2 in 1. And then they further get a release of the end product into the cell. They break down and thrown out through exocytosis. This is something which I want everybody to understand, how this whole process of phagocytosis takes place within the cells. Having talked about neutrophils, which is the highest number, let's talk of the second, which eosinophil count. Nucleus is plus, you can see in the picture. Number is 3%. Diameter is what, 12 microns again. 2 lobes with a thick spectacle. If you look at the picture, it looks more as if they are like you are wearing spectacles. Granules contain basic proteins, eosinophilic protein, glycoproteins, phosphate, histaminase. These are the things which center around eosinophils. The prime function and objective is weak phagocytosis. Neutrophil very strong. This is weak. Act on parasites, larvae, releasing hydrolytic enzymes and highly reactive form of hydrogen. The concentration of eosinophil, normally 3% out of 6,000, could be 180. But when the concentration can go up to 2,000 per cubic millimeter, it's called eosinophilia. And that normally happens when you have parasites in the body, you have infection, you can lead to asthmatic attack, and many of those things. And those things are very common with things I learned when I was in ENT department doing my post-graduation. Those 3 years, we saw plenty of it, and we had to take care of that with diethylcarbamazine, and that tablet works on worms as well as eosinophil count, and make sure that eosinophilia is not there, cough and cold is not there, and you don't suffer from asthmatic attack. This is something which I would definitely like everybody to remember, that eosinophilia is that particular problem. Basophil cell. As you can see, the right and the top color is blue, basofilm is blue, nucleus is plus. Number is 1% or less than 1%, diameter is 14 microns, slightly little bigger than other two lobes with a thick S connection. There is an S connection. Basophilic cytoplasm with granules contain heparin, histamine and serotonin. Granules can be seen on top of the nucleus. You can see blue granules big on top of the nucleus. A mild phagocytosis. So you have strong neutrophil, mild eosinophil, and very weak is eosinophil count. And allergic reaction and chronic hypersensitive reactions cause a viral infection, allergic reaction, and chronic myeloid leukemia. Basopenia means reduced number of cells, and that could be because of steroid therapy. And you can also have a basophilia when its number could be more than 1%, 2%, 3%. But these 3 granulocytes are the first thing which are very important for everybody to understand and implement from WBC count. Having explained that, now let's move on to Agranulocytes. Monocyte is the first cell. As you can see, the nucleus is plus, almost 40 size, and it looks more or less like kidney beans, rajma. Number is 6%. Many a time this can show along with lymphocytes that you can be confused because they look almost identical. Diameter is almost like 22 microns. Is almost double the size what you normally see in neutrophils. One lobe without a globe. Nucleus kidney shaped, 40% that cytoplasm. Prime function, defense through phagocytosis. Again, it is phagocytosis. Tumor immunity, blood monocytosis, produces cytokines, hemopoietic factors. Monocytes circulate blood for 72 hours. They leave the blood to enter the tissues and become tissue macrophages for months together. And they can be used as different cells in different ways over a period. That's the beauty of monocyte. They play a very important role to make sure if it is acute infection, it will be neutrophil. If neutrophils are not able to take over, then monocytes could take as the second line along with the lymphocyte to make sure that you will get the immunity come what may. If this system is understood, I think we are very clear how we understand white blood cell structure, shape, functions, physiology, macrophysiology, pathology, diseases, and treatment. It's very simple to understand the whole thing as an integral integration, horizontal as well as vertical, to put together. Okay, this is what it is all about. Next comes to the lymphocytes. As I told you, you can see the picture right on top is a lymphocyte. This picture and of course the last one what you have seen in monocyte more or less look the same. Only thing is this size is much smaller than two. There are two sizes, small cell and large cell. Small cell is as good as neutrophils. Large could be a little bigger than that, but not as big as monocytes. That is something which I want everybody to understand. Lymphocytes are small as well as big, and they are formed in bone cells, particularly put together called axial bone cells. You have peripheral bones as well as axial. To start with, they all form throughout, but over a period they shift to maximum axial bones alone. As you can see right on top, the first one, stem cells in red cell marrow give rise to undifferentiated lymphocytes. That is the first part you can see in the picture. You can see red bone marrow, very clear in red, and from there the two cells are coming. B cell you can see down, and then also this another B cell, which is undifferentiated lymphocytes, get transformed into B cells and go to T cells in thymus gland to form what we had written in number 2 is some undifferentiated lymphocytes are persist in the thymus gland to become T cells. T means thyroid, B means bone marrow. This is something to be understood very clearly. At this particular juncture, that is understood, we'll be able to understand immunity much better when we take it up as a next for immunity. So T cells go and blood transfer, go to the lymph nodes. Green on one side are the lymph nodes. Left is a bone, up is a thyroid. This is lymph node, and how they come to lymph nodes, how they are destroyed, how they demolish the whole thing, and then come forward is something which has to be understood very clearly. And we are going to take the next process of immunity to understand how lymphocytes play a role in beta cell and immunity desired immunity by and large. That itself is a big picture, so it's being made separately. Right at the bottom you can see some undifferentiated lymphocytes are processed, probably within the bone marrow to become B cells. As I told you, all to start with the undifferentiated, you cannot differentiate in B cells or T cells. Some which become B, they travel towards lymph nodes and they do all the phagocytosis and all the function in that to make sure that everything is done within the lymph nodes, everything is destroyed and eliminated, and we become free from all sorts of viral infection to bacterial infection to fungal infection to any infection. That is what it is all about. Number 4, both T cells and B cells are transported through the blood to lymphatic organs such as lymph nodes, lymphatic ducts, and spleen. Spleen is the last one, which is on the left side of the upper abdomen, where all these cells are broken and converted. RBCs also go there, break it down, and they're recirculated. WBCs also go there, and all the final clarification takes place in spleen. And at this particular juncture, let me tell you, spleen is the only thing which has only sympathetic blood supply, no parasympathetic nervous system supply. Only in case of emergency, spleen contains 150 ml of blood. In case of loss, that sympathetic system will squeeze it and bring it down to extracellular fluid to replace the blood volume, to make sure that blood volume does not come down, blood pressure is maintained, and we can lead a perfectly healthy, wealthy, wise and happy life. And that's the reason it goes only to spleen, not to anybody else. That is something again which I want everybody to understand, how beautiful is our human nervous system, human blood system, all the 10 systems of the body, how beautifully along with endocrine systems through homeostatic factors they put together and make human body as a perfect example of physiological life, psychological, emotional, mental, spiritual or otherwise. A human being is the only one who is capable of doing wonders from A to Z, provided it is able to understand its perfect anatomy, perfect physiology, perfect biochemistry, perfect psychology, and all the matters which are absolutely essential. You can be perfect physically, emotionally, mentally, spiritually, integrated, religiously, otherwise, such a perfect, you are in tune with universal consciousness, and entire universe would talk through you, whatever the universe is all about. And all the secrets of the universe will be revealed to you, provided with honestly as a perfect human being, 100% truthful, totally non-violent, totally satisfied, and just working for the love as if you are like a God, living God on the earth, and doing things for the benefit of everybody. Nature will stand by you. You will literally become a living God like any other incarnations we are talking about. Whether we are talking of Rama in Ramayana or Krishna in Mahabharata. Similarly, there are so many gods and goddesses and so many saints, sages, prophets of the entire world who have spoken in tune of the universal consciousness. They are the living example, provided they all stand by truth, non-violence, non-possessiveness, non-acquisitiveness, and have the universal benefit of all the beings, living, non-living, everything in mind. You would become one with universal consciousness. And this is the objective of videos, one by one. Having spoken about it, now let's go to the next. Next is, as I've told you, I'm not going to take much time on this because concentration was on white blood cells. 3 agranulocytes, 2 granulocytes. The ratio is that. And what is the percentage? How to remember, how to consider, how to go about it so that we can reproduce the whole thing systematically without any problem has been well taken care of. Now let us prepare ourselves for the next stage called immunity stage. Thank you very much. Thank you.